Hey guys, so this is just the short lesson that we did in class today when a lot of you were on a field trip, and I think you'll be okay with a video version of it, so here we go. So the first six I already have written out because they're pretty common sense, I would say. If you take the limit as x approaches a of a sum, that's actually equal to the sum of the limits. All right, so basically a limit of a sum is equal to the sum of the limits. So you can kind of just like expand it out. Similarly, the limit of a difference is equal to the difference of the limits. The limit of a product is equal to the product of the limits. Again, so common sense, we're just expanding it. The limit of a quotient is equal to the quotient of the limits as long as the denominator is not equal to 0. If you take the limit of a constant times a function, that's equal to the same as pulling the constant out and doing the constant times the limit. And lastly, if you have the limit of an n root of a function, that's the same as the nth root of the limit of the function. All right, so you can pause the video and write those down. I don't think we need any more than that. Okay, so something that we did in class that I also want you guys to see is off to the side. What is the square root of x squared? I just want you guys to think about that. A lot of people think that you just cancel them and it's just x. That's actually incorrect. This whole squaring a square root canceling business only works for positive numbers. But then if you think about it, well, what if x was -1? Well, if you square a -1, it's +1, and then the square root of 1 is +1. So it turns out if you have the square root of x squared, it's not x, it's the absolute value of x. It's going to always be positive. All right, so again, we talked about it in class. Everybody thought square rooting a square cancels, it's just x. It's actually not, it's the absolute value of x. Okay, so that'll help us with number 1. If you have this limit, instead of crossing off square rooting a squared cancels, what we just talked about, this is really absolute value of x minus 2, all over x minus 2. All right, so then if we want to find the limit as x approaches 2, we need to find the limit as x approaches 2 from the right, and then we need to find the limit as x approaches 2 from the left, and we need to see if they're the same or different to see the limit as x approaches 2. So if you're coming at 2 from the right, then these are both going to be positive versions of the same number, right? Because if you're coming from the right, you're going to plug in a number bigger than 2. That's going to give you a positive and a positive. So then when they cancel, it reduces to 1. But if you're coming at it from the left, you're plugging in numbers that are less than 2. Well, that'll make this positive. But if you're plugging in a number less than 2, it's going to make this one negative. Okay, so instead of being 1, this sided limit will be -1. And then because the one-sided limits do not match, then the limit does not exist as you approach 2. All right, so nothing too new right there. Number 2, also not super new. This one is going to be one of those conjugate ones. If you try to plug in 0, you get a 0 over 0, which means we have to use one of our tricks. And for this one, I'm going to use conjugate. So I'm going to do root t minus 2 plus root 2 and root t minus 2 minus t plus root 2. Remember, for the conjugate, you just change the sign to plus and plus. All right, so you guys know how to do conjugates. We're going to FOIL the top. A root times itself will just become 2 minus t. And then the inners and the outers are going to cancel. So I'm just going to skip that. And then the last, negative root 2 times positive root 2 is just negative 2. And then in the denominator, I'm actually not going to distribute. I'm going to leave them separate. T times root 2 minus t plus root 2. All right, let's see what happens. 2 minus 2 cancels. And then actually, t over t cancels, but you are left with this negative. So it's negative 1 over all this. Root 2 minus t plus root 2. I keep calling 2t. And now that everything is gone from the denominator, we can go through with plugging in the 0. All right, so if you plug in 0, you end up getting negative 1 over, what's that, root 2 plus root 2, so 2 root 2. And you can leave it unrationalized. If you want to rationalize it, multiply by root 2, then negative root 2 over 4 would also be fine. So either one. All right, and then this last one is a little different. Hopefully you guys remember from algebra that if you raise something to a negative power, it just flips it and it becomes a fraction of itself. So this is actually going to become 1 over 3 plus h. And 3 to the negative 1, hopefully you guys know, is just 1 over 3. And now we're just going to have to simplify. Because if you plug in 0, you're going to get 1/3 minus 1/3, which is 0 over 0, which we can't do, so we have to use one of our tricks. All right, so now in the numerator, we need to get a common denominator. And the common denominator would be a 3 and a 3 plus h. Now let's adjust our numerators. This one has the 3 plus h, so he needs the 3. This one has the 3, so he needs the 3 plus h. And don't forget then, this is all still over this h. All right, so that's going to equal. If we clean up the top, we can distribute the negative sign, and we'll be at 3 minus h all over 3 times 3 plus h all over h. And then the next step, 3 minus 3 cancels. So now we're at negative h over 3 times 3 plus h all over h. But you guys know dividing by h is the same as multiplying by the reciprocal, 1 over h. And then now the h's cancel, and we're left with negative 1 over 3 times 3 plus h. And now we can plug in 0. All right, so if we plug in 0, that'll be our limit. So that ends up being negative 1/9. All right, that's what you guys missed in class. Hopefully this wasn't anything too crazy. It's just kind of some more complex algebra, right? The assignment is the attached worksheet, which I'll send you guys. It's 1 to 47 odds. All right, so if you could finish that for tonight, then you'll be all caught up in class tomorrow. All right, thanks for watching.